So, hello everyone. Good evening. So here we shall start from question number 1 in the exercise 2, which is based on midpoint theorem. So here it is given that in triangle ABC, D, E, and F, are respectively the midpoints of points of AB, BC, and CA respectively. So it means that if we draw a triangle ABC, then C is the midpoint of AB, E is the midpoint of BC, F is the midpoint of CA. So we have to join DE and F, and we have to show that triangle ABC is divided into 4 congruent triangles by joining DE and F. These two sides are same, these two sides are equal, these two sides are also equal. Now we have to prove that triangle ABC divided into 4 congruent triangles, by joining D, E, and F. So how to prove it? Proof is simply first we will tell that E and F are midpoints of AB and AC respectively, since it is given. So therefore, we can say that DF is parallel to DE. DF is parallel to DE. And D, or I can say DF is parallel to DC. DF is parallel to DC, and DF equals to half of DC. DF equals to half of DC also. So which is equal to DE by using the midpoint theorem. Using the midpoint theorem. And also, since it is given that, and also it is given that DE equals to half of DC, since E is the midpoint of DC. So now you can say that in triangle ADF and triangle DBE, you can say that angle ADF, that is equals to angle DBE, since corresponding angles are equal. Since corresponding angles are equal, as here DF is parallel to BC. ADF is angle ADF is equal to angle DB. And also AD equals to BD. AD equals to BD. And DF that is equal to BE. DF equals to BE, which is equal to half of BC. DF equals to BE, which is equal to half of BC, which is proved above. And also here, the reason is that since D is the midpoint of AB, is the midpoint of AB. So therefore, I can say that triangle ADF, triangle ADF that is congruent to triangle DBE, triangle DBE by SAS rule of congruency. By SAS rule of congruency. SAS rule of congruency. Also, it is given that BE is equal to, also BE will be equal to VC, which is equal to half of BC, since it is given that E is the midpoint of BC. So we can say that EC equals to DF also. EC equals to DF also, which is equal to half of BC. So now we can say that in triangle ADF, in triangle ADF, in triangle FEC, triangle FEC, angle angle AFD that is equal to angle FCE, FCE. Since by corresponding angles are equal, since corresponding angles are equal, as this DF is parallel to BC, as DF is parallel to BC by using the midpoint theorem, and also AF equals to FC, since F is the midpoint of AC. F is the midpoint of AC, which is given also. And obviously EC is equal to DF, which is proved above. So therefore I can say that triangle ADF is congruent to triangle FEC. ADF is congruent to triangle FEC by SAS rule of congruency. SAS rule of congruency. So now in these two triangles, also we can say that in triangle ADF and triangle here. Also, we can see that also DE, also DE is parallel to AC. DE is parallel to AC. Means by using the midpoint theorem, as D and E are the midpoints of AB and CB. D and E are midpoints of AB and CB respectively. DE is parallel to AC. So I can say that. So in so I can say that DE equals to half of AC, which is equal to FC by midpoint theorem only, by midpoint theorem. Hence it is equal to half of D is equal to half of AC. So I can say that. So D is equal to half of so D is equal to FC we have shown, and DF is equal to EC also we have shown. So now therefore now in triangle, now you can see that in triangle DF DEF, triangle DEF and triangle CFE, triangle CFE, you see that, and that EC equal to DF, EC equal to DF is proved above, and DE is equal to CF, DE is equal to CF is also proved above, or proved earlier we can say, and EF is the common side, and EF is the common side. So therefore, I can say that triangle DEF is congruent to triangle DEF is congruent to triangle CFE. Triangle CFE by SSS rule, by side rule of congruency. So hence we can see that all these four triangles are congruent to each other. So therefore we can see that triangle ADF is congruent to, we have shown that is congruent to triangle DBE, which is also again congruent to triangle FEC. ADF is congruent to FEC, triangle FEC. Therefore, this will be congruent to, so F corresponds to E here. So that will be congruent to triangle EF, triangle EFD. So hence you can see that hence triangle ABC is divided. Triangle ABC is divided into four congruent triangles. Four congruent triangles by joining D, E, and F. By joining D, E, and F. So hence proof. Then here it is told in L, M, and N are three parallel lines intersected by transversals P and Q such that L, M, and N cut off equal intercepts AB and BC on P, show that LM and N cut off equal intercepts D, E, and EF on Q also. This is D. So now it is given that L, M, and N are three parallel lines which are intersected by transversals P and Q, such that L, M, and N cut off equal intercepts AB and BC on P. Then we have to prove that L, M, and N cut off equal intercepts that is DE and EF on Q also. Then we will write the proof. No, first we will write the construction. The line segment AF is drawn. Which intersects BF at G. Then we'll write the proof. So here we will write the proof, that is so here we will say that so AB equal to BC in triangle AB in triangle ACF, which is given. And BF is parallel to CF, which is parallel to AD, which is also given. So hence I can say BG is parallel to CF. Hence we can say that hence G is the midpoint of AF. G is the midpoint of AF. Yeah, G is the midpoint of okay. This E or F I have to understand. We see D, E, and EF. So this is E, and this is F. This is E, D, E, and this is F. So I will say that AF is drawn, which intersects DE at G. So here G is the midpoint of AF. And BE is parallel to CF, which is parallel to AD. So this is E actually, this is not F. This is E actually. So BG is parallel to CF, and so G is the midpoint of AF by using the converse of midpoint theorem. By using the converse of midpoint theorem. Since why the converse of midpoint theorem says that if a line is drawn through the midpoint of one side, which is parallel to the third side, then it will also intersect the midpoint of the another side. So it means that if I draw a line through the midpoint of AB, say D, and then it is drawn parallel to BC, then it will intersect AC also at a point E, which is also the midpoint of AC. So that is the statement of the converse of midpoint theorem. Similarly, okay, so therefore we can say that AG equals to GF, AG equals to GF. And similarly, in triangle FAD, this is D part, this D. So in triangle FAD, GE is parallel to AD. Hence, it is given that BE is parallel to AD, and G is the midpoint. G is the midpoint of AF, which is proved above. Is proved above. So therefore, I can say that E is also the midpoint of DF. Is also the midpoint of DF by using the converse of midpoint theorem. By using the converse of midpoint theorem. So therefore, you can say that DE equals to EF. So hence proof. E equals to EF. So simply we have to say that LMN cutoff equal intercept D and EF on Q also. Or simply it means we have to show that D equals to EF. So if we can show that D equals to EF, then hence it shows that LM and N will cut off equal intercepts D and EF on the transversal Q also. So hope all of you understood the solutions of these questions till question number of question numbers 1 and 2 in the exercise 2. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. So thank you everyone.